Hello everyone, and welcome back to another episode. Today we're cracking open a question that I've seen pop up everywhere. Are eggshells good for plants? You've probably heard it before. Someone says, just crush up some eggshells and throw them in your soil. But is this actually science or just gardening folklore? In this video, we're going to talk about what nutrients are actually inside eggshells, how long they really take to break down, why crushing them doesn't make nutrients instantly available, how to collect and clean them properly, and finally the different ways you can use them in your garden or grow room. But before we begin, please remember this is an educational video, and all information provided is for educational purposes only. Now let's get into it. Chapter 1. What's inside eggshells? Picture this. Every morning, millions of people crack open eggs, make breakfast, and toss the shells straight into the trash. But what if I told you those discarded shells were actually a slow-release mineral supplement for your plants? It might surprise you to learn that eggshells are composed of about 94 to 97% calcium carbonate, while the remaining few percent consists of magnesium carbonate, calcium phosphate, trace minerals like potassium and sodium, and a thin inner membrane rich in organic proteins. And that's not insignificant. Calcium carbonate is chemically stable, structurally strong, and biologically important. In plants, calcium plays a critical role in cell wall formation and is essential as it supports plant growth, protects against pathogens, and maintains turgor pressure. It also acts as a dynamic barrier that enables the plant to withstand environmental stresses and remodel for development. Furthermore, calcium stabilizes pectins in the middle lamella, which is the thin layer between plant cells, essentially acting like glue as it creates calcium bridges that hold plant cells together. This is important because without a strong middle lamella, individual plant cells cannot adhere tightly to one another, weakening the overall structure of the tissue. When this bond is compromised, stems can become fragile. New growth may appear twisted or distorted, and rapidly developing tissues like root tips and young leaves can lose integrity. In a fast-growing plant like cannabis, where structural support is essential for both vegetative expansion and heavy flower production, a stable middle lamella ensures that cells remain firmly connected, allowing the plant to grow upright, transport nutrients efficiently, and withstand environmental stress. Beyond structure, calcium also functions as a signaling molecule inside plant tissues. It helps regulate nutrient transport, root elongation, enzyme activation, and stress responses. So when growers talk about strong stems, resilient growth, and overall plant structure, calcium is often part of that conversation whether they realize it or not. Now that we've covered some background on today's topic, I want to take a moment to thank the sponsor of today's video, Mars Hydro. Since 2009, Mars Hydro has been making indoor lighting and equipment more accessible to growers. One of their products that I think could be helpful to both new and long-time enthusiasts is the FC 6500 730-watt LED grow light. This state-of-the-art light uses Bridgelux 3030 LED chips, giving growers strong light output with solid efficiency. It also includes a full-spectrum design utilizing Osram 660 nanometers deep red chips. But a grow light can have great specs on paper and still perform differently depending on how that light spreads across the grow space. That's where the smart control side becomes really useful. When paired with Mars Hydro's smart controller and PPFD sensor, you can schedule dimming and adjust light intensity. And that brings me to another Mars Hydro product I wanted to show you, the iFresh Aeron 6 Smart 2-in-1 Inline Duct Fan. Instead of having a separate inline fan and carbon filter taking up additional space inside the tent, Mars Hydro combines both into one compact unit. The Aeron 6 uses a 6-inch EC-powered fan capable of moving up to 305 cubic feet per minute of air, while the integrated activated carbon filter helps remove odors from the air being exhausted from the grow space. Through the Mars Pro app, growers can manage fan speed, create schedules, use timers, and set climate-based triggers. And Mars Hydro has another product that takes that idea quite a bit further. the iHub 4 AC 2.0 Smart Power Strip. Now, one important thing to understand is that the iHub 4 AC isn't designed to operate by itself. It's an expansion device for Mars Hydro's eye control system. Once connected to eye control, it gives you 4 individually controllable outlets that can operate in manual, timer, cycle, or environmental modes. And to me, that is the real advantage of smart grow equipment. It's not that you suddenly stop paying attention to your plants. It's that you don't have to spend as much time doing the same repetitive tasks every single day. So whether you're trying to automate more of your equipment or just make your grow room a little easier to manage, Mars Hydro is here for you. And if you decide to make a purchase, you can use discount code GUY for 3% off. Thanks again to Mars Hydro for sponsoring today's video. Now let's get back to today's topic. Chapter 2. The importance of pH. To truly understand the benefits of using old eggshells with cannabis plants, we need to examine the one factor that controls nutrient availability in any garden: pH. pH is a measurement based on a scale from 0 to 14 that tells us how acidic or alkaline a substance is. A pH of 7 is neutral, numbers below 7 are acidic, and numbers above 7 are alkaline. Cannabis prefers slightly acidic conditions, typically between 6 and 7 in soil. This range is critical because pH directly affects nutrient availability. If pH drifts too far in either direction, nutrients can become chemically unavailable, leading to deficiencies that are not caused by lack of nutrients, but by lack of access. This is where eggshells enter the conversation. Calcium carbonate has an alkaline pH of around 9 to 9.5. That means when introduced into acidic soil, it can gradually help raise and buffer pH over time, much like agricultural lime. However, and this is critical, eggshells are not a fast-acting pH adjustment tool. Calcium carbonate dissolves very slowly under normal soil conditions. So unless the soil you're using is both acidic and biologically active, the short-term impact on pH will be minimal. And while eggshells do contain small amounts of magnesium and phosphorus, the levels are relatively minor compared to dedicated fertilizers or compost inputs. So if you're expecting eggshells to supply all the calcium needs of a heavy-feeding cannabis plant within a single grow cycle, that's not really going to happen. Chapter 3. How eggshells actually break down in soil. This is where many growers go wrong. You cannot simply crush the shells, throw them into soil, and expect them to instantly dissolve into a plant-available form. Under normal garden conditions, eggshell fragments can take months to years to fully break down. So if you drop a whole eggshell into soil, it may sit there largely intact for years. But if you grind that same shell into a fine powder, you dramatically increase its surface area. More surface area means greater contact with moisture, microbes, and organic acids. And greater contact means faster breakdown. This is why simply crushing eggshells with your hands is not enough if your goal is nutrient availability within a single grow cycle. For best results, the shells should be thoroughly dried, lightly baked to remove residual moisture and pathogens, and then ground into a fine powder using a blender, coffee grinder, or mortar and pestle. However, it is important to understand that even in powdered form, calcium carbonate does not dissolve instantly. In moist, biologically active soil, initial microbial interaction can begin within days, but measurable breakdown typically takes several weeks. It is still slow release, but significantly faster than large fragments, making it better suited as a long-term mineral amendment rather than a rapid correction tool. Chapter 4. How to collect and clean eggshells. When it comes to eggshells, the color of the egg or whether it's labeled organic does not make a meaningful difference for your plants. White eggs, brown eggs, chicken eggs, duck eggs, they are all composed primarily of calcium carbonate. The color comes from pigments related to the breed of the bird, not from differences in mineral content. So, from a soil amendment standpoint, a shell is a shell. What does matter, however, is cleanliness and proper preparation. Fresh shells often contain residual egg white and inner membrane material. If left on, that organic residue can attract pests, create odor, or introduce unwanted microbial activity in your soil. So start by rinsing the shells thoroughly under running water to remove any remaining egg material. You don't need to scrub aggressively, but you do want to eliminate visible residue. Next, allow the shells to dry completely. You can air dry them for several days, or speed up the process by placing them in the oven at around 200 degrees for 10 to 15 minutes. Light baking not only removes moisture but also helps sterilize the surface and makes the shells more brittle, which improves grinding efficiency. Next, grind the shells into a fine powder and store in a container until used. Chapter 5. How to use eggshells. So now that we understand what eggshells are made of and how they break down, let's talk about how to actually use them in your grow operation. The most effective way to use eggshells is as a pre-mixed soil amendment. Once the shells have been ground into a fine powder, they can be blended directly into your soil before planting. This allows beneficial microbes time to begin the slow breakdown process before roots are fully established, which will contribute to the long-term mineral balance of the soil. When it comes to how much to use, moderation is key. A safe and practical guideline is about 1 to 2 tablespoons of finely ground eggshell powder per gallon of soil, or roughly half a cup to 1 cup per cubic foot of soil. That's enough to provide a gradual calcium contribution without dramatically altering your soil chemistry. Over-application may reduce the availability of certain micronutrients like iron and manganese, especially in soils that are already near the upper end of the ideal pH range. Another way to introduce them to your garden is through compost. This is one of the smartest and most effective methods for using them in your grow, as compost environments are biologically active, warm, and often slightly acidic, which are all conditions that help accelerate the breakdown of calcium carbonate. In a well-managed hot compost system that reaches temperatures between 130 and 160 degrees Fahrenheit, finely crushed shells may begin softening within a few weeks, but complete decomposition often takes 3 to 6 months. For best results, crush or grind the shells before adding them to compost. One additional point growers should understand is that eggshells do not add nitrogen to compost, so they should be balanced with adequate carbon and nitrogen sources to maintain proper compost ratios. Now, one of the most popular ways to use eggshells in your gardens is by making a tea. The idea sounds simple. Extract calcium from the shell and make it immediately available to your plants via a tea. But this is where chemistry matters. Plain boiling water alone does not extract significant calcium from eggshells, as calcium carbonate is not highly soluble in neutral water. You can boil shells for an hour and still extract very little usable calcium unless an acid is involved. When you add a mild acid like vinegar to eggshells, the acetic acid reacts with calcium carbonate and produces calcium acetate, a water-soluble form of calcium that plants can absorb much more readily. If you'd like to make a simple calcium extract, place about half a cup of eggshell powder into a glass jar and slowly add enough white vinegar to fully submerge it. Let it sit uncovered or loosely covered for 24 to 48 hours until the bubbling stops. At that point, most of the reaction has completed and you are left with a crude calcium acetate solution. It is important to note, do not tightly seal the container while it is actively bubbling, since gas buildup can create pressure. Also remember, this concentrate is strong and should always be diluted before use. A practical ratio is about 1 tablespoon of the calcium acetate solution per gallon of water. It can be applied as a soil drench during vegetative growth or early flowering when calcium demand increases. Finally, let's talk about top dressing. Top dressing refers to the practice of applying an amendment directly to the surface of the soil, usually around the base of the plant, rather than mixing beforehand. The idea is that water, microbial activity, and natural soil processes will gradually move nutrients downward into the root zone over time. If you choose to top dress with eggshells, it should always be as a fine powder. Top dressing works best in outdoor beds, raised beds, or long-term living soil systems where the soil ecosystem is active and ongoing. And that, my friends, brings us to the end of today's episode. If you found this video helpful, don't forget to like, subscribe, and hit the bell icon so you're always up to date with our latest content. And I would love to hear from you. Comment below with your thoughts, questions, or experiences. Thanks again for watching. And until next time, keep being awesome and stay curious, my friends.